So in the last video, we talked about terminal points, which are these points that exist on the unit circle at, well, any angle really, but we specifically covered the terminal points that exist at 30 degrees, 45 degrees, so pi over 6 radians, pi over 4 radians, pi over 3 radians, pi over 2, and any real multiple of those. And then these coordinate points that we're really interested in. This video is a slight deviation from that. We're gonna take a small break from talking about those points, even though they are arguably the most important part of this class. And we're simply going to take a look at this circle and talk about this circle specifically. We're going to talk just about some of the things that make sense about working with this circle in the first place, which, as a reminder, this is the unit circle. And the unit circle has an equation, x squared plus y squared equals 1. If anybody's wondering where it comes from, there is, hopefully in pre-calc 1, we learned that the equation of a circle that is centered at the point h comma k has this equation. And so for us, our h value is 0, our k value is 0, and our radius here is just 1, and that leads to this equation. And so specifically what we're talking about for this section is arc length and sectors. So we're going to tackle arc length first. And so arc length is exactly what it sounds like. What we're talking about is the ability to measure curved parts of a circle, right? The length of the curved part of a circle at any section between any two angles. So for instance, if I asked you, on the unit circle, what is the length from pi over 6 radians to say, 2 pi over 3 radians, I'm specifically talking about the arc length between those two angles. And if it's on the unit circle, of course, the answer will be different than if this was on a circle that was really, really large. Okay, so we're going to talk about arc length, and there's a formula for it. There's a formula for arc length. Okay. So arc length typically is associated with the variable s. Okay, why is that the case? Actually, it's just because in higher level mathematics they use s for arc length. And so that's kind of what we're going to do as well. There's a formula for it, and the formula is as follows. It is that the arc length of some circle is equal to the radius times the amount of movement or the angle that exists between from the center out to the edge of the circle, and then however long your segment is. So what do I mean by that? So let's erase this, and let's simply talk about why this formula makes sense. So why does this formula make sense? Okay. One thing to note is that the angle here, this angle is in radians. Okay, in radians. Now, why does this formula for arc length make sense? Well, let's do an example, right? So by example, this should make it abundantly clear. What is the arc length of an entire circle? Well, I'll just say of the entire unit circle. We'll keep it simple. Of the unit circle. The entire unit circle, Okay, and so we ask ourselves this question. It's not too bad because the radius of our unit circle is 1, and if we're talking about the entire unit circle, we're talking about going all the way around the unit circle. Then how far have we traveled? Well, the radius is equal to 1 of whatever our unit is, and theta is going to equal 2 pi, right? Theta equals 2 pi, and so the arc length here, should just equal 1 times 2 pi, So our answer is that the arc length is just 2 pi in whatever our units are. That is kind of, it could be the worst pi that has ever been written in the history of the world. Let me fix that. Pi, there we go, that's a little bit better. Okay, and so that would be the answer. Now, why does this make sense? Because you may remember that the circumference of a circle, which measures the total distance around the edge of a circle, right? The circumference of a circle is given by the equation 2 pi times r. And this should make complete sense because if we're talking about the arc length of an entire circle, this right here is my theta for any circle of radius r. That right there is going to be the angle, okay? So if we're talking about arc length, that's what we're talking about, okay? So it's this formula. It's pretty simple. It's actually so simple. It's very, very just cut and dry, cut and paste. This is kind of what it is. So sometimes in examples, they might say, they might give you something like this, and they say, what is the angle, or excuse me, what is the arc length of the angle here that is subtended by this arc. So they use the word subtend or subtended. Basically, that's just a fancy word of saying, they want this arc length for the angle that is inside of this little kind of, curved triangle, if you will. Okay, that's pretty much as fancy as it gets. So what are the uses of this? It's useful if, say, you want to build a curved wall or something, or maybe you work in an optometry department and you're trying to determine, how long a certain lens has to be, right? If it needs to experience a certain amount of curvature or something like that. So it has its uses to be able to determine, the distance, the length of curved objects, okay? And these are very specific to circles. It's not just a random curve, right? That requires a little bit of different math, which you will learn in your calculus class, but it's specific to arc lengths of circles. All right, so the next thing that's up is sectors, and specifically what we're going to be talking about is sector area, okay? And so what we're talking about is if we have a circle, and we'll stick with our old friend, the unit circle, so keep things nice and simple. If we have our friend, the unit circle, a sector is simply referring to the area that is trapped in a particular region, okay? So that could be a sector. Maybe there's a sector over here, and we're talking about the area trapped in this region. It's the area in the slice of pie. And this also has a formula, and so the formula is 1/2 theta times r squared. Now, why does this formula make sense? So again, intuition, right? Intuitively, right? The area of a circle is what? Area of a circle is what? Well, the area of a circle is pi r squared. And this kind of makes sense because you can kind of think like if I take this formula and I say for the entire circle, right? So for the entire circle, if I ask what is the area of the entire circle, then theta here is 2 pi, and we would cancel out the 2's with the 2 in the denominator, and we'd just be left with we'd just be left with pi r squared for the area of our sector. So again, this formula kind of matches. And if you're ever having trouble remembering these formulas in a homework or an exam or something like that, I'd encourage you to just think of, well, I can always go back to, if I want area, I know the formula for area of a circle. If I want arc length, I already know the formula for circumference of a circle. And you can kind of work backwards and just build these formulas from scratch. So for instance, if I asked you for what is the area, right, between, say, so example, what is the sector area between pi over 6 and we'll say pi over 3 for the unit circle, Okay, so we are basically interested in this area right here. Well, it's not too bad because we know that the radius is 1, and we also know that the angle that's inside of here, if we're going from pi over 6 to pi over 3, which is 30 degrees to 60 degrees, the angle in there is pi over 6. And so we use the formula, and we're going to get that the area is equal to 1/2 pi over 6 times the radius squared, like so. And so that just leads us to pi over 12 times, well, 1 squared. So 1 squared, which is just pi over 12, and then whatever our units would be, or to match. So if we were, for instance, filling up with cement, right? If I needed to cement in this part of this circle, maybe it's a swimming pool or a walkway or something, I would need maybe pi over 12 square feet of cement or something to fill it in. And so that's it. That's right there is the area of a sector. Okay. The last thing that we are going to cover, actually it's going to be in the next video. So we're going to cover linear and angular velocity. That's going to be next section, but this one is short and sweet. Just talking about some properties of circles. Again, this will show up on your homework. It's not going to be the most important thing we learn in this class. It's more kind of like fun trivia to know. It will definitely resurface if you are going in the STEM field and you are planning on taking Calculus 3 and Calculus 4. These concepts will come back in full force, but for now, they're more just kind of like, this is something we can also do with this thing called the unit circle. We can talk about arc lengths. We can talk about the areas of these little sections, and we will kind of see applications for that in the future. So that's going to be it for this video, and I will see you in the next one.